guys. So my name is Lauren Voswinkel. I am at Lauren Voswinkel on Twitter and Valerisa on GitHub. I work for Gigapan Systems, and we make robots that help you take really awesome pictures. It started off as a collaboration between CMU, Google, and NASA to stitch back images that came back from the Mars rover's Spirit and Opportunity. So anything that you saw back in like the 2005, 2006 era that came back from Mars was probably the stuff that eventually became Gigapan Systems. So that's pretty cool. But I'm not here to talk to you about that. And before I talk about putting off persistence, my slides are up here. So if you can't read the code, feel free to grab the slides and follow along on your laptops. So I'm here to talk to you about something that I never really thought about too much in my development process, which was persistence. When I was doing things with Rails on any side project, I took the typical route of going through, starting up a new Rails app, throwing in a bunch of generate scripts, and getting a whole bunch of models out that were already tied to active record. So this is phenomenal because it gets you up and going really, really fast. But the problem with going really fast is you tend not to think about things, and when you tend not to think about things, you end up in a ditch. This service talk before talked about the monolithic Rails app, and anybody who's had a mono Rails app knows that after a while you start bogging down and getting really slow, and it gets very difficult to change things as time goes by. So how many people here have actually started a Rails project using Active Record and said, you know what, I'd love to switch to NoSQL for some part of this? And then going down the road, you started working with that and started trying to pull it out and realized, I said I would be done with this in 2 weeks. Oh my God, I'm nowhere near that. So anybody that's tried doing it, it's a painful process because of how linked into our project's Active Record actually is. So here's the concept. Take some time, think about your big decisions. Alternatively, put off making those decisions as long as possible. Sandy Metz has said in her talks, you will never be as ignorant about your project as you are right now. And this is a fact that a lot of us have taken to heart. But then there's a question. Why, in the name of sanity, do we make one of our biggest decisions about our projects right off the bat? Your database will have an impact in how your project grows. It will have an impact on how easy it is to scale, and it will have an impact on how you model your data. So it's my personal belief and experience that developing the features of an application before committing to a data store is one of the biggest advantages that you can take in your process. But before we get into this, some history. I tried building an application dealing with managing events and schedules many, many times using the typical Rails way. I went in, threw in the generate scripts, and had 30 migrations by the time a week was over, and it just didn't work. And then I eventually decided, you know what? Let me go back and just wipe the slate clean again. And by this time, Corey Haines had released the first episode of Building an App with Corey Haines. And so I followed along with this. And in that episode, there was some really interesting concepts to developing an application in which the first part didn't involve using persistence at all. And so I was following this on a step-by-step kind of iteration, and then got to a point where I was going along at a very nice rate, and then the episode ended, and I was kind of left being like, where do I go from here? So I took this concept of putting off decisions to an extreme. Here's the basic cucumber scenarios that I eventually wrote. These were really simple Just there's no events to display. There are some events to display. Check that information. Here's the definitions for it. Very, very basic. Defining events in the there are some events definition, and visit the URL. The page should have content of there are no events listed at this time. All very basic behavior-driven development, simple steps. This is where it gets interesting. In this process, developing with as little code as possible to get the test to pass, we have an event that is just a struct, has a status and display. This is defined in the controller class. Well, outside of the controller class, but on the same page as the controller. And then inside the controller class, the events collection is just an object with 3 methods on it built into the controller class. And those are upcoming events, current events, past events. Those take a block, and that block allows you is what you use to display each event that's defined inside of the method. And then the event view is just pretty basic. It goes and says, here's the upcoming events, here's the current events, and the past events. So let's add the concept of filtering by dates. Crap. This is the first time that I encountered where I had to pull out the information from the controller and actually go and create a model. And so I thought here, well, maybe this would be a good point to actually start using those generate scripts. I was like very hesitant on doing it. And so I decided at this point, let's not do that. So let's just create a normal plain old Ruby object. And then we're going to go through and we're going to put it into the test. But then I ran into a problem where you couldn't access the information in the test scope or in the view scope from the model. I needed some way to persist that information from the model into the controller and then into the test, or into the view to be checked by the test. So what I thought, what do I think? Maybe I'll just make an array. I mean, it's a solution, and yeah, it's not perfect, but I was actually able to get past this original barrier by creating an array that every time an event was instantiated, it just pushed itself onto a class variable array. And here is the code for that. The main points to be looking at are the self.events method, which all it's doing is instantiating an empty array if it doesn't exist. And if it does exist, then you just have that array. And if you don't return any, or if you don't give it any parameters, you just return that array. If you give it a parameter, in this case, a range, it will filter that using a select of the array. And if you give it a block, such as in the view, it will iterate over that list and spit out or interact with your code using the block. And then in the instantiation, there's just a push onto that array that gets returned when there's no parameters passed into it. So it's pretty basic. And then I pulled out the scoping methods, upcoming, current, and past events, into this class, and really nothing changed at that point. So it's using the same class level instance variable, and just interacting with it how it normally did otherwise. So here's where the big change happens. I pulled out all of that other code that set up what event was and set up the methods and everything. And now I'm just having it create a date range if parameters were given in the URL. And if they weren't, just sending nil instead, and that just gives the entire array. So again, pretty basic. And then the view, doesn't change at all. Because of the behavior-driven development, I was able to refactor without changing any view code whatsoever, which was kind of neat to be able to play around with the back end so much and have absolutely no changes happen in the view. The problem is this is a lot of wheel inventing, because ORMs actually have most of this functionality would just be afforded by an ORM. So why am I doing this? I'm doing this because an ORM as a package provides you with all of these different connections and ways to interact with your domain model and how those objects in your domain interact with each other. It just gives them to you right off the bat. The problem with this is that these connections tend to cause like a leaking encapsulation. So you start creating connections and utilizing those connections without really paying attention to it. And because of that, I actually see more violations from the law of Demeter because of ORMs than through any other means. So one of the biggest benefits of doing this part is that you start having to craft an internal API, how your objects are interacting. Every single one of those methods needs to be made specifically for your domain. You are choosing every way that your objects are interacting. It seems really verbose and really painful to do, but it is very, very informative. Because you're paying attention to these processes, and you are feeling the pain of connecting your methods or your classes and having this happen, these interactions happen, you start being aware of pain points more quickly as well. And pain, in this case, is good, as are foul odors. Code smells, in this case. Pain's good in this instance because it's a warning flag. As you start creating all of these different methods for having your objects interact with each other, you start seeing a web being created, and you can avoid that web. It allows you to address pain early on so that you don't end up with trauma later, like a 30-minute code test suite to run. My words are getting jumbled. And it also forces you to pay attention to your decisions. This is, again, really important to think about. But using an ORM, using the normal Rails methodology, we tend not to think about these decisions. So this process gets us out of that box. So moving on. We left the code in this state where we had events being pushed onto an array, and the class was managing that array. I added a cucumber feature that says the events displayed are only within a specific range, and it just checks to see, oh, OK, I've created date ranges for the events, and those date ranges are actually doing the comparisons of what is and is not being displayed when given a specific date range. In this case, 5 days ago to 5 days from now. And then there's the conditionals that say, I am seeing an event or a list of events within the range. So pretty basic. But now let's add the ability to scope by date and calendar. So we're creating this concept of what a calendar is, that you have specific events listed on that calendar and specific events listed in another calendar. So let's create that. And we hit the second roadblock. In our code, we're constantly returning an array. So obviously, one solution we could do is monkey patch the array. And this is a terrible, terrible idea. Really never do this at all. If you find yourself monkey patching basic Ruby data types due to a special case situation, you're doing it wrong. Please don't do that. So I had to think about another solution that wasn't as horrifying. And so I thought, what if I created a class that manages lists of events, and in that class returns an instance of itself with that scope? Well, this kind of reminded me of Java. And I don't really like Java, what with its horrible classes that manage lists of things and then classes that even manage lists of lists. It's just a terrible, terrible thing to think about as a Rubyist. But then I got to thinking about it, and I realized when you aren't relying on a database, you can't make a 2-millisecond call out to the database that returns a collection for you. You start having to actively manage the information that you're storing. So you have to start creating these classes that have lists of your other classes. And so really, Java did something right. That's OK. I guess I can deal with that as a Rubyist. I like trashing Java quite a bit, but I guess it's cool to say that it can do some things right. Really, these things were created for a reason. So we're going to look at the event model at this point. And I've created, rather than the simple push onto an array, it is now passing itself to the event list event pool. And the event list event pool, I have to skip a slide because I put them in the wrong order. The event pool is just that same array saying, OK, if I don't exist, instantiate me as an empty array. And then it's pushing, the method previous is pushing itself onto that array. So that's neat. What does everything else look like? Everything else looks pretty basic, what with the current events saying, OK, we're doing the same thing where we're looking at events, which in this case is returning the array, and then selecting based on the status or based on the calendar. And if I go back, the belong to is just some meta programming to say if there is anything that says like calendar underscore ID or like job underscore ID, and I respond to that and it equals this object's ID, then I belong to it. So this is just doing the select statements on that event, and then passing that collection to the event list instantiation. And the event list instantiation is then up at the top saying, if I am passed a collection, rather than using the event pool as a whole, I'm going to set events to what I was passed. And we're just working based on contract. You could be evil and send it like an array of strings or something, and it would probably cry, but don't do that to yourself. And then the delegate methods is me creating dynamic methods that send anything that hasn't been overwritten in the event list API to that array. So I can use .each, I can use include, and other array-based functions without defining them because I have that. I do this instead of relying on method missing because method missing tends to give you like horrible stack outputs, and I don't like dealing with really terrible traces. So I use dynamic methods. And if you don't know the difference between dynamic methods and ghost methods, Paulo Perrotta, who wrote the Metaprogramming Ruby book, gave a talk at Madison Ruby last year in 2012 called The Revenge of Method Missing, and I highly suggest watching that because he explains all of the different ways that metaprogramming interacts and like how you could use ghost methods instead of dynamic methods. And there's a wonderful twist at the end, which is really funny, and I suggest you watch it. Regardless, now I've got this shiny new event list. But once again, it seems like we're doing a lot of unnecessary work. The concept of method chaining is something that belongs in every ORM that's worth its salt. So why do we need to go through and do this? What's the benefit? The benefit, again, is encapsulation, but also, in this point, single responsibility principle. Having methods that deal with collections of themselves is a violation of the single responsibility principle in that nowhere in your business logic or in your domain logic do you have something that says a user should be able to deal with a list of users. If you do have that, that's really strange. And I'd like to talk to you afterwards, because that would be an interesting project. But probably you don't deal with that. And so you should only really be defining these collection-type behaviors on types of basically persistence. But it turns out the event list is actually a type of persistence. It is in-memory persistence. So in addition to that, I know this kind of sounds like a lot of hyperbole and like, oh, a single responsibility principle, you don't really need to stick to that. But the problem is, by not separating out those concerns, when you have a change to the ORM that you are utilizing, then that starts affecting your domain logic. And you start having to dive into the classes that should just be all domain logic and should only be testing domain logic. And suddenly, you switch to a new version of Rails, and they've changed active record 2 to active record 3, and you find everything's wrong. So really, anybody here who's done a Rails 2 to Rails 3 migration probably knows the pain that I'm talking about. So in this case, again, pain is good. Also, surprise is bad. By extracting the collection management into a separate class, we now have that API that we are managing and is what's interacting with our objects inside of our own domain. So we know every single method that is being used throughout our code base because we wrote it. So when something changes with the ORM, you know exactly where to go to change that implementation once and only once and not have to worry about it propagating through your code. So what we're doing in this case is creating an abstraction between our code and a third-party library, in this case, the ORM. So what I just mentioned is that this also gives us extensive knowledge of our API because we're writing everything that we need. And this in turn mitigates the surprise when we need to make changes, like I said before. So at this point, I found that in the process that I was going through, I didn't really have any more particular insights on how to create new pieces of the in-memory persistence layer. So basically, at this point, I could go through and continue iterating and developing features without really having to interact too much with new problems that came up because I was doing this without persistence. So it's a pretty small investment overall in that there was very little experimentation, and then I just continued interacting with the same problems in different classes. So eventually, as we continue to do this, we get to a minimum viable product. And at this point, we've put off persistence, but now we need it. So it was fun, but our users are going to want to come back and see stuff that they did before, rather than just have everything that they wanted to save get destroyed when the process kills itself. That would be bad. But before we get to how to implement persistence, I'd like to talk about how this has helped in other ways. Other ways that this has helped, particularly me, is it gave me a lot of new insights into how my code interacts with libraries. It also gave me new insights into how I shape my classes. So in this instance, I showed you the date range class, which is something that I had never really considered doing before. That is, creating a class that manages dates by itself without any other type of responsibility involved with it. And that really, I think, is because of what I like to term persistence-determined responsibility. What this persistence-determined responsibility is it's very, in a lot of instances that I've seen, what you store in the database tends to become in your mind something that belongs to that class. So if you store events with dates in them, you start thinking to yourself, oh, the event should be what's dealing with the date range. Which is really problematic when you start seeing that date range concept show up in other aspects of your code, and then you have to start rewriting code. And that's not really that fun. We don't like rewriting code. So what I'd like to talk about next is actually composition. It's your friend. Composition is phenomenal because what it allows you to do is create relationships between classes that are stored in different tables by creating other classes that manage pieces of the behavior. In this case, the event class actually delegated responsibilities relating to its start date and end date to the date range class. And what that allows me to do is when I created other objects that had the concept of dates, I could just reuse that date range class and suddenly have instant ability to compare those objects. It was basically free features, which was awesome for me. Also, because you're not duplicating features or code, you then also save your sanity, and saving our sanity is good. So, the next thing about how this has helped is that it's created a persistence layer and persistence-based objects, which, again, brings us back to the concept of encapsulation. We now have objects that are related specifically to our collection's concerns. That also leaves the single classes by themselves to talk only about our domain and our business logic. And it also reduces the coupling that we have between our persistence and our business logic. This eventually saves you headaches if you continue maintaining something for an extended period of time. One of the other ways that it helps is that this actually gives you case-by-case persistence methods because you've abstracted out how you are storing the information, suddenly you don't care. Your business logic doesn't care how it's being stored. I can send it to memory, and it will work perfectly fine. I can send it to a database, and it will be perfectly fine, be it MySQL, NoSQL, or I can even send it to memcached or as a cookie to our client. It doesn't matter. That's no longer a concern of my business logic or my domain. It is a concern of the other classes, which means I can then say, let's store events using NoSQL, and let's store everything else using MySQL. Or let's not even store half of these things and just do in-memory or memcache-based storage. And then if that gets lost when the memcache server goes down and we have to start it up again, that's perfectly fine. We'll just build the cache again. One of the last points that it helps is that our domain has been modeled prior to our implementation details. Uncle Bob Martin actually had a rant about this about a year ago, where he was infuriated by this concept of having your persistence be one of the first decisions that you make because it ends up warping how you model your business logic. It ends up saying, you end up looking at a problem and saying, well, I could do it this way, but this database doesn't really support that, so I'm going to do it this way instead and make it really kludgy. That's not good. So really, we should be modeling and testing our domain logic before we actually think about any implementation detail like persistence. So that's really cool. But now how do I add that persistence? Do I have to restart? Is this just a spike for fun? Well, it's actually not really that difficult. Turns out it's already something that's pretty much been talked about and is an existing pattern. The pattern is known as the repository pattern, which was most prominently described in Martin Fowler's book, Patterns of Enterprise Application Architecture. And specifically, what we've created is an in-memory repository that's implicitly saving when an event is created. So in order to interact, say, with active record, which is what I ended up doing anyways with this entire process, I ended up having to think about how to hook in active record and how I could utilize the in-memory event list, the in-memory persistence as a testing feature without, while having the database persistence be what I used in production and integration tests. So unit tests use in-memory. Everything else uses database. So what we have here is actually a blueprint with the event list of an in-memory event module. Unfortunately, I needed to start using modules because active record's a pain in our proverbial butts, and it uses inheritance to interact with our objects. And that hooks deeply into our domain modeling classes. And so we end up having to overwrite a lot of the behaviors that active record gives you automatically in order to change the behavior that we want. In this case, storing into in-memory or storing into various other places that aren't MySQL. So talking about now overriding active record, how do we actually override active record? Well, the things you need to worry about are save methods, finder methods, and validations. All of these things are things that you need to actively overwrite in order to ensure that you are properly encapsulated against when you're doing unit testing. And so by only relying on the API that we've created, we then implicitly know what methods we need to override in order to change the behavior drastically. So in other words, when we start adding active record, we're not going to start using the different associations and whatnot that are provided by default. We're only going to be using what we've created already. And what this does is stops us from accidentally shooting ourselves in the foot when suddenly we lose that encapsulation and need to change persistence and find out, wait, we have our code strewn throughout our classes. So our event list methods become the API that we're programming to. And an example of what this would look like is I would actually also suggest creating a persistence library that then has the different persistent methods, and in this case, active record, and then specifying the class name in the module. And so that when I'm putting it into the event class, I'm saying persistence, active record, and event, and that's saying I want it to be using specifically what I've written. You do need to extend active record base because of how active record works, and that makes me sad, but that's fine for right now. And then when you get to your tests, in this case, your unit tests or specs, you can basically say active record base is an empty object. And then you can say send, you can use send to tell the class to extend persistence, in-memory persistence, and the event. And what that does is basically say is, OK, take the in-memory library that we've created and stick it into our stick it into our class, and we'll be good to go without having to rely on active record at all. Alternatively to that, you can basically create nosy or coupled collections that kind of reach into the objects that it is managing, and then pulling out that behavior and kind of like doing a weird like reach around to doing a weird reaching in to extract the actual database persistence that we're utilizing. So the active record event list would look something like this, where you have the event pool is now redefined as just event.all. So it's reaching in and pulling out the entire collection as an active record association object. And then inside all of the scoping methods, you're just utilizing .aware to scope that, and then returning that as that active record association object so that you can chain. So that's one way to do it in addition to the modules. So if you don't like modules so much, this is a great way to create that, to not create, but to keep that encapsulation and rigid barrier between your domain logic and your persistence logic. There's also a whole bunch of other things that you could do to implement this. There's libraries that can be utilized, like Virtus and Hyperion, that manage, Hyperion manages repositories. Virtus just enforces type so that you can say, okay, I've got the event class, let's create the event list class and say, okay, an event that it is managing has these characteristics. And you basically create that contract between the collection and the object that it is collecting. And then there's also other implementation details that you could use with other libraries like DataMapper, MongoMapper, Mongoid, et cetera, so on and so forth. So really interesting, so many varied ways to actually approach this creation of adding your persistence to the project after this in-memory event list has been created. So what we're effectively creating by doing this is a series of adapters that handle your library and your code to the different persistence methods. So whether it be NoSQL or SQL or cookies or memcache or whatever, you are creating these adapters that are interchangeable and switchable. And you can actually build in hooks that would allow you to persist to two different methods at once. So it creates a lot of flexibility for your work. So to conclude, basically everything that I did with this whole project, I found out later was this in-memory repository layer. So it was kind of a clever ruse I played on myself to get me to do more object-oriented type functionality that I didn't really think about. And then when I looked at it afterwards, I was like, oh, people are already talking about this. Cool, I'm not talking out of my ass. This is awesome. And it's quite a bit of extra work, but doing the initial legwork and actively thinking about the decisions in our process really yields a lot of interesting insights that we then can use to really think about our domain models more. And it gets us out of boxes that we would otherwise be in. So if you find yourself creating a new project and you find yourself opening up the generate scripts and everything, take a step back, breathe, relax, and maybe put off some persistence. Okay.